Good morning children, myself Neelam, and today we are going to study the chemistry subject for 7th standard, and this is session 1. Today we are going to begin with a new chapter in chemistry, and the name of the chapter wherein we are going to study is matter and its composition. I repeat once again, matter and its composition. The most important word over here is matter. If you understand this word matter, then what does it composition? You will easily understand. Composition means content, right? So first you need to understand the word matter, right? So this matter word you have been already studied in 6th standard, or you have been already heard in 6th standard. But this is the recapitulation again into the 7th standard. Now what this matter meant by, what this word matter is meant by, right? So matter is nothing but anything that occupies space, anything that occupies space and has mass is called as matter. Any substance which has mass and occupies space, right? Now whatever the substance which are present in this universe, whatever the present which are present in this universe, the smaller one to bigger one, right? The shorter one to taller one, whatever the substance, the shorter tree, the shorter sapling to big tree, right? The smaller board to bigger board, right? So all this, substance are made up of a tiny particle which is nothing but called as matter. And now what this matter is, anything substance that occupies space and has mass. Means the two important words are there, that occupies space and has mass, right? It's nothing but called as matter. Now let's understand this thing with very one example, right? Whatever the things, whatever the substance we are utilizing from morning till the night when we go to the bed, all that substance is nothing but considered to be a matter, right? Whatever we are using, right? The basic fundamental needs like food is nothing but it is a substance, right? When you take the food in your hand, that means it occupies the space in your hand and it has a certain mass, the weight, therefore the food is considered to be a matter. The cloth which you wear, right? Now cloth is occupying the space on your body, and if you weigh it, it has a certain weight, right? Therefore the cloth is also considered to be a matter. The pen, the very pen, if you take in your hand, it is occupying the space in your hand, but when you weight it, it will be having a certain weight, a mass. Therefore the pen is considered to be a matter. The pencil, each and every component or the substance which is there in this universe is considered to be matter. Because matter is that thing, matter is that substance which occupies space, which is occupying the space and has mass. For example, if I am standing in front of you, that means I am occupying the space on this earth, right? And even I weigh certain amount, right? So therefore I am considered to be a matter. The very table when you keep on the ground, the table will occupy the space on the ground and it will weigh certain amount. Therefore the table is considered to be a matter. The very fan is occupied the space on the ceiling, right? And it has a weight, it has a mass also. Therefore fan is considered to be a matter. So what is matter is all about? Matter is that substance which occupies the space, and has a mass, right? So for example, if I take this chalk, right? So if I hold the chalk in my hand, it is occupying the space in my hand, right? And when I just keep it on the waving balancing beam, it will have certain weight also, mass also. Therefore this very chalk is also considered to be a matter. No matter anything, maybe it is living being or non-living being, all these are nothing but it is a matter, right? So what is matter is all about? Matter is a substance which occupies the space and has a mass, right? So that was all about the matter. And this matter, when we recap about the 6th standard, right? In 6th standard also you observed or you heard this word matter. You might be doing the recapitulation. Now matter is consist of two things. Matter is consist of two things. First is substance and that transformation. First is substance and that transformation. That substance will study here, but right now we will understand the basic terminology which are associated with matter. Right? Now the second terminology wherein we are going to study is volume. That is volume. Now what is volume is all about? The space anything occupies. Volume is the space wherein any substance will occupy the space. Now if I am standing here on the ground, the space is there. Now if I am standing on this space, that means I am occupying this space, right? So any substance which is occupied by that space, right? Any substance wherein it is occupying the space, that substance is having a certain volume, right? Anything that occupies this space. I repeat once again, anything means any substance that occupies the space. Any substance which occupies the space is called as volume, right? Let's understand this with the help of an example, right? If I take one football and the another one tennis ball, if two balls I took, which is bigger? The football is bigger than the tennis ball. If I took those two footballs and keep it on the ground at one place, now this is a football and this is a tennis ball, right? Now football and tennis ball, when I keep it on the ground, which will occupy the more space, the football or the tennis ball? Obviously the football will occupy the more space, because football is much more greater than the tennis ball in mass, right? Football is weighing more than the tennis ball, right? So we can say that the football has a greater volume than that of the tennis ball. Football is having greater volume than the tennis ball. So what is volume? Volume is nothing but anything that occupies the space. Now this is the space on the ground. When I keep the football is occupying the space, right? So the football is occupying the greater space when you compare with the tennis ball. The reason behind that is the surface area of the football is much more greater than that of the tennis ball. When you compare with the weight also, football will be much more greater in size and weight than that of the tennis ball. So what the example says, the space of football is greater than the space of tennis ball. I repeat once again, the space of football is greater than the space of tennis ball. That is, the volume of football is greater than that of the tennis ball. So what is volume is all about? Anything that occupies the space on the ground or anywhere else. Anything substance which occupies the space on the ground or anywhere else, it is considered to be its volume, right? So example wise, we took the two balls, which is football and tennis ball. So when I keep the football on the ground and the tennis ball on the ground, which will take the more space? Obviously the football, right? Now then the third one, the third terminology wherein we are going to deal with is mass. What is mass? Right, these are the basic terminology. When you go towards the higher standard, you should know about all these basic terminologies, right? Now mass, the amount of matter anything contained. I repeat, the amount of matter anything contained is called the mass. Amount of matter which is contained within that substance is nothing but called as its mass. For example, if I take one water bottle, right, and if I take a glass, right, if I take one water bottle and one small glass, now which will occupy this water more? If I take 1 liter water bottle and a small glass and I fill each of them with the water, the water bottle will take the more water into it. The water bottle will be filled with the more water into it when you compare with the glass and weight it. Then what will be the mass? Whose mass will be more? Obviously, the water bottle mass will be more when you compare with the glass. Why it is so? Because the water bottle is bigger in size and the glass will be smaller in size. When you pour the content into water bottle and in the glass, the water bottle will fill more water into it. That means the water bottle contain more content, more matter, right? So what is the mass? Anything which has a more content, anything, the amount of matter, anything content, means the amount of substance, anything it contain, right? The amount of matter within that substance content is nothing but called as mass. As such I said in the example, when you take the one bottle and a small glass and you pour it with the water, the content which are the amount of matter you are pouring into the water bottle will be more. The amount of matter, the amount of liquid wherein you are pouring in the liquid water bottle will be more than that of the glass. Now here what example they had given, let's see. The full glass of water weighs more than the half glass of water. Now they had given very simplified example. I took an example of water bottle and a glass. These people are taking an example of a two glass. When you pour one glass with a full water and the second glass with a half water, which will weigh more? Obviously the glass which contains full water. The glass which contains full amount of water or till the mouth. Wherein the glass which contains half water, it will weigh less, right? So what is mass? Mass is nothing but the amount of matter anything contain. The amount of matter anything contain means any substance which contain that much amount of matter within it, right? So if I take an example, suppose if I take an example of chalk and a thick rubber band, a small chalk and a thick rubber band, that means a very thick one, right? So the amount of matter in the chalk and a thick rubber band, which will be more? Obviously the amount of matter into the thick rubber will be more because it contains more matter, it contains more component when you compare with the chalk. So this thick rubber will be weighing more. The mass of the thick rubber will be more when you compare with the small chalk. Right, so that was all about the mass. So we studied the three basic terminologies. First one is matter, second one is volume, third one is mass. So all these terminologies are linked or associated with each other. Now we'll do recapitulation of these three terminologies once again. Now what is matter? Matter is anything or any substance, I repeat, anything or any substance that occupies space and has mass, right? Anything or any substance which occupies space and weighs certain amount is nothing but called as matter. Example, the food we eat, the cloth we wear, the living being, non-living being, any component which are existing in the surrounding or the nature are nothing but they are called as the matter. The very air, the air which you breathe in, the oxygen which you breathe in, air is also considered to be a matter. Why air is considered to be matter? Because air is having its component, different mixture of gases are present within that, right? So air is also the matter, right? Because it occupies the space in the atmosphere and it weighs some amount with the gases which are present over there, right? So that was all about the matter. Now what is volume? What is volume? Volume is nothing but anything that occupies the space. Any substance which occupies the space is nothing but called as volume. For example, we took a very fantastic example or amazing example of one football and tennis ball, right? Football is greater in size and tennis ball is smaller in size. So when these balls, when you keep on the ground, which will occupy the more space? Obviously the football will occupy the more space. Therefore we consider that football has a greater volume than that of the tennis ball. Then the third terminology was mass. Now what was the mass? Mass is nothing but the amount of matter present within the substance. The amount of matter that anything contains. In simple language, if I want to explain, the amount of matter that any substance contains, right? It's nothing but called as mass. I repeat once again, the amount of matter that any substance contains. It's nothing but called as mass. For example, when you take 2 glass and one glass if you fill with the full water and the another glass with the half water, which will weigh more? Obviously the glass which contains the full amount of water and the glass which contains half amount of halfly filled, it will weigh less, because the amount of matter present in the full glass water is more than the amount of matter present in the half filled water is less. Right? So that was all about the 3 basic terminology. Now we will study the state of matters. Now in 6th standard we have been already did with the state of matters. There are how many types of state of matters are there? Everybody knows that there are 3 types of state of matters. Right? Matter exists in 3 states. Matter exists in 3 states. And what are those? Solid, liquid and gaseous. What are those? Solid, liquid and gaseous. Now what is solid, what is liquid and gaseous? We will study in more depth about the mechanism or the process or the content what it contains. Right? Now we'll understand the example first. Right? Now in basic example for solids are nothing but ice. Basic example we'll take. Right? Ice is solid in nature. Right? Because the particle of ice are tightly packed with each other. Right? And the smallest particle which are present within that solid particles are nothing but called as molecules. We'll deal with that later on. Right? When solid, liquid and gaseous we will study in more detail. But first we'll understand the example, how the solid is correlated with the liquid, how the liquid is correlated with the gas. Now ice is an example of solid. Right? You know that what is ice? Ice is nothing but whenever you keep the water at 0 degrees Celsius in refrigerator, that water molecule get converted into ice, right, which is a solid in state. Right? Now when you keep the water into the refrigerator at 0 degrees Celsius, it converts into ice. Now when you heat this ice, what does that ice will convert into? In which state of matter does the ice will convert into? Obviously the ice will start melting when you heat and it will get converted into water. Right? And what is the state of matter for water? The state of matter for water is liquid. Right? Now when you further heat the water, it will convert into water vapor. Right? So ice is getting converted into water on heating, and water on further heating it gets converted into water vapor. Now what is water vapor? Water vapor is nothing but the steam which is arising when you heat the water, the steam or the gas which is evaporating after the boiling, right, of the water. Right? So this is a one forward reaction. This is a one forward reaction, means this reaction is first going in the forward direction. Right? Now this water vapor which is there, the gas or the steam which is there, on cooling, right, it gets converted into water. How come the water vapor is getting converted into water by cooling? I'll give an example. Where your mama is cooking food, basically the rice. What will happen when the rice is cooked? The steam is getting evaporated from the water. Boiling rice, the steam or the water vapor is getting evaporated. When she keep the lid on the vessel, what will happen? In the inner side of the lid, the water droplets are formed. Right? Did you observe this? Because the water vapor, when it gets stick to the inside part of the lid, the water vapor will get converted into the water droplets. Means on cooling, when it comes in contact with the atmosphere or the surface of the lid, it becomes cool, right? And on cooling, that water vapor get formed into the water droplets or convert into the water state, right? So water vapor on cooling or on condensation, it get converted into water. And water on further cooling, when you keep the water at 0 degrees Celsius into the refrigerator, what does the water get converted into? Ice. Water on further cooling, it get converted into ice. So we'll recap once again. Solid, that means the ice, on heating it get converted into water. Water on further heating, it get converted into water vapor. And water vapor on cooling, now the reverse reaction. That was the first forward direction reaction. Now this is coming back to the reverse. backward reaction. Forward reaction and then backward reaction it is. So here water vapor on cooling, it gets converted into water. Water on further cooling, it gets converted into ice. So the state of matters are correlated with each other. The content within all this ice, water and water vapor is nothing but water molecule only. The content or the matter which are present within all this, ice is containing the water molecule, water is also containing water molecule, water vapor is also containing the droplets of water molecule. The content or the matter among this all these three state of matter is same, right? Okay, now once again solid is getting converted into liquid, liquid is getting converted into gas, and on backward reaction, backward direction, gas is converted into liquid and liquid is converted into solid, right? So this is a correlation between solid, liquid and gas. Okay, now in this we have studied, what we have studied, first thing, what is the matter is all about, and the basic two composition, the basic two fundamental terminology over here is volume and mass. And apart from that, we also studied the state of matters. The state of matters means there are three types of state of matters wherein you are keep on studying from your lower standard itself, that is solid, liquid and gases. Right? Now this solid, liquid and gases, how they are correlated with each other, we saw with the help of an example. Okay children, now here we begin with a new topic or the new concept, which is the continuation of state of matter. We were aware that there are three states of matter, the solid, the liquid and the gas. Now how these three states of matter were correlated, that also we studied. Now the basic concept or the new topic we are going to start again is what causes the difference in state of matter. What causes the difference between these three states of matter? The basic difference which exists between these three states of matter, so called solid, liquid and gas. Why solid is called as solid, why liquid is called as liquid, and why the gas is called as gas. So what is the factor which makes the basic difference between these three states of matter? That we are going to study here, right? Okay. Now matter is not a continuous. Matter is not a continuous substance. Now what was the matter? Matter is nothing but it is anything substance which has mass and occupies a space, right? So that matter is not in a continuous state. Then what will be there within the matter? Right? There should be certain thing within the matter which is not making it continuous, right? So what is the most important content? That is nothing but the composition, right? First we understood what is matter and what are the basic terminologies which are associated with the matter. Now hereby we are going to study the composition. What makes matter to be discontinuous is nothing but its composition. Composition means content. So this is the basic meaning of the chapter, matter and its composition, right? So what is its composition? Now here we are going to study, right? Now matter is not a continuous. So if it is not a continuous, then what is there within it? What is making it discontinuous? Let's study here. It is made up of smaller particles. Matter is made up of a smaller particle, very tiny particle which is called as molecules. Now suppose this is a matter. This is a matter. The square one which I had drawn over here, it is a matter. Anything, the substance which occupies space and has mass is nothing but called as matter. I repeat once again, anything which occupies space and has mass is called as matter. Now this is the matter. The second statement says that the content within matter. What does the matter composed of? The matter is composed of tiny particles, this white color dots, tiny particles are nothing but called as molecules. So what are molecules? Molecules are nothing but the tiny particles which are present within the matter, right? So now second one is, now if the molecules are present within this matter, this molecule should be held with each other. If one molecule is here, another molecule is here, another one is here, so they are at certain distance. if one molecule has to get closer to each other, there should be certain force between them. Suppose this is one molecule, this is the another molecule. There should be certain gap, and this gap is filled by certain attraction, and there is a space also, right? So let's understand this thing one by one together. Now there is some small gap or some space. There is some space between the molecule, right? If this is the molecule and these molecules are there, there is some space, this yellow color shading which I had done. This yellow color shading is nothing but called as a intermolecular space. What it is called as? Intermolecular space. Now what is intermolecular space? Space means gap, right? The gap between the molecules, right? Inter means between. Inter means between. What is the meaning of the word inter? Inter, between means whom? Molecule. So between the molecules there is a space. If one molecule is located here, another one is here, another one is here, so there is a gap between them, right? So that gap is called as, or that space is called as intermolecular space, right? So we will recap once again. What does the matter composed of? Matter is made up of a tiny particle called as molecules, right? And these molecules are having space between them. Some space are there between the molecule, which is called as intermolecular space. This yellow color shading, the yellow color shading is nothing but called as the intermolecular space. Inter means between. Between the molecule, the space is there, right? Now the third point says that the molecules are held together. The molecules are held together, right? These molecules, 1, 2, 3, these molecules are held together by certain force, by force of attraction called as intermolecular force or cohesion. I repeat once again, the molecules are held together. The molecules are held together by force of attraction called as intermolecular force of attraction. Now intermolecular force of attraction means what? Now this is one molecule, this is the another molecule. One molecule has to be held by the another molecule, right? Means if one molecule is here, another molecule is here, these two molecules are held together. They are joined together by certain force, certain attraction, which is nothing but called as intermolecular force of attraction. Intermolecular, see, between, inter means between the molecule, force is there, right? So between two molecules or three molecules there is a force, and that force is nothing but called as intermolecular force or cohesion, or it is also called as cohesion. So here the intermolecular force of attraction. So you can see this yellow color arrow, this is one molecule, this is the another molecule. So these two molecules are held together by force, and that force is called as intermolecular force, right? Or it is also called as cohesion, or it is also called as cohesion. So this is a basic component which is present in the matter. We repeat once again, matter is not a continuous substance, right? It does not have any continuously things in that, but it possesses certain component within it, right? So what does the matter is made up of? Matter is made up of, or matter consists of smaller particles. Matter composed of smaller particles called molecule, right? It is called as molecule. So what is molecule? Molecule is a tiny particle or smaller particle present in the matter, right? Now second terminology you should aware is intermolecular space. Now what is intermolecular space? Intermolecular space is a space within which the matters are existing. There is a small space between a molecules. There is a small space between a molecule called as intermolecular space. Called as intermolecular space means this yellow color space which is existing between the molecule is called as intermolecular space. And third terminology you have to remember is intermolecular force of attraction. I repeat once again, intermolecular force of attraction. And what was that? That it was saying that the molecules are held together by force of attraction called as intermolecular force of attraction or cohesion. So this three terminology you have to remember. First is molecule. this word, molecule. Now what is molecule? Molecule are the tiny particle in the matter, right? Okay, now second one is space. What is space? Space means gap. Gap between whom? Between the molecules. So the space which is existing between the molecule is called as intermolecular space. Third one is what? Force. What is a force? What does this force do? It makes to held together the molecule together, right? It helps the molecule to be enclosed with each other or to be attracted with each other, right? So if one molecule is held with the another molecule, there should be certain force, and that force or cohesion is called as intermolecular force or cohesion. So what does the matter composed of? Matter composed of three most important elements. First one is molecule. First one is molecule. Second one is intermolecular space. Third one is intermolecular force or cohesion. Once again we repeat, what does the matter consist of? Matter consists of three most important elements, right, or constituent within it. First one is molecules. What is molecule? Molecule is a tiny particle present in the matter. Then second one is intermolecular space. Now what is intermolecular space? Intermolecular space is a space which is present within the molecule, the yellow color one, shaded one, right? Now the third one is intermolecular force. Intermolecular force. Intermolecular force means the force which is needed to hold the two molecules together, right? These two molecules or three molecules are to be close with each other or held together, and that force or cohesion is called as intermolecular force of attraction. Force of attraction, right? These are the constituent or the element present in the matter, or we can say that these are the composition of matter.